The next presentation is also a stand-in. Doug Vaught wasn't able to attend the meeting today, so Rich Stromberg agreed to come and talk about icing in Alaska. What a beautiful picture we have here. Rich is relatively new to Alaska, is currently working in the wind program at AEA, but in his what, 2 years?
A year and a half.
Year and a half, he certainly come up the learning curve quite well, understanding wind, but understanding Alaska, picking up some of the native language, which is a quite remarkable feat. Rich, when he's not kind of out with his dog paddling around, he's either up at his cabin or at the homestead he built out in Colorado. So Rich, a new addition to the Alaska wind community.
Thank you very much. There'll be just a little overlap between the previous presentation and mine, but hey, it'll just reinforce your learning. Okay, a little bit about icing and what you see in clouds. And this is, I stole this from one of our National Weather Service guys in Juneau. And I think it shows a good picture of temperature and within a cloud. Just because you see a cloud doesn't mean there's rain or there's ice. There's several different things going on in the cloud. You can see down here at the lower levels where the temperature is above 0 degrees C, you can have liquid water in the cloud. Here in this range is where you get more of your supercooled water down to -15, and then down to -40 there is more of a mixed phase of there's still some supercooled water here, and below -40 though there really should be no supercooled water. This is another way to represent it. There's kind of a continuum of where you have all liquid in your cloud versus all ice, and it's not an either or. It's just as the temperature changes, you move from mostly liquid to mostly ice. So it's more of a probability of icing. I think the comment that John made was that they're seeing icing down to 30 C, and you still have low levels, but in the right conditions you can still have icing accumulating on hard surfaces. And this is another nice, really nice probability graph here that shows kind of this range, temperature range in here is where there's the highest chance for icing to occur, but you can still have, there's different probabilities out in some of these other conditions as far as the liquid water content in a cube of air and the actual temperature. And this also represents how there's a real sweet spot for a lot of icing, -8 to -12 C. The other thing they know is there's research that's been done to show that the rate of icing is higher at different temperatures for different substances. So whether you're dealing with aerosols or pollutants or volcanic ash or bacteria in the air versus hard surfaces, there's some different ideal icing conditions. And there's overlap, and it's all distributions and probabilities, but there's kind of this magic -8 to -12 where you see a higher rate. Just because you're not in there doesn't mean you're not going to see icing at warmer or cooler temperatures. So here's typical icing that we might see at a Met Tower site. This was Atkasuk, and this is actually Doug Vaught, one of his photos. And this comment is pulled straight out of the Wind Resource Report. It says data recovery at Atkasuk was marginal, with 63 to 73% of the data returned from the anemometer and wind vanes. So a significant amount of loss, about 30+%. The missing data represents the windier winter months when data recovery was extremely poor. Poor data recovery was due to soft rime ice beginning in October and lasting to early May. So we have a long season up here. Here's an example of Manicotac, and actually I thought I had a different. Yeah, I think I copied in the wrong graph on this one. There's a period in Manicotah. Here in this winter season, we actually had no icing periods at all, whereas the following winter, there was a 2.5 month period right in here where there was no data collected at all. And it's not that we had icing during those entire periods, it's just that we had significant amount of icing such that it never melted off for that entire period. So this is an example of you do one winter's worth of measurement and you might not see an issue that the subsequent year hits you pretty significantly. Now let me talk about Nome. We've had some experience with icing there. The community of Nome actually sits down here, and then there's the coast, just runs right along in this region here. And there's a couple different wind sites that we've studied. There's the Banner Wind Farm actually sits on this ridge right here. Anvil Mountain, there was a Met Tower put up there a while back. That site was abandoned due to icing. That's the highest peak. Although you can see it's got better wind resources, Class 5 wind, versus down here we're looking at Class 2. And then we decided to look over here on Newton Peak as well and see what the resources were looking like. A little bit lower elevation than Anvil Mountain. These arrows also indicate the predominant wind direction, black being the primary wind direction and green is the secondary wind direction, to give you a feel for where's the windward and leeward side of different ridges. So kind of, if you take this previous map and we're going to kind of cut it crosswise this way, just cut a profile there. The coast would be out here, and as moist air moves in and it gains in altitude, it loses its ability for that moisture to be held in the air, and it starts to condense out. It also cools and gets down to that temperature range where you can start to get icing. So some of these peaks is kind of what we're seeing in that area. So we're up on Newton Peak and life is good. And, you can see it's not a whole lot of snow. It's fairly wind blown up here. Not very deep snow working on this entire ridge. This is when we went back up in April. We had a tower collapse in December, and it took us a while to get up there and assess the site. We did that in early February, then went back in April and set up a new Met Tower. This right here is a FAA transmitting station it's a transmitter and solar power to power those electronics. And so we've got our nice our Met Tower standing here. This is a 34-meter tower. And we put it up on the 8th, and it ran pretty good. Had some nice winds continued to build in the storm. We just barely missed it in time to get the tower up. And then, boom, about noon on the 10th, 2 days later, everything shut down. We can kind of see where our wind direction is coming from out of the south for a while, and then it shifts around to the north. And then right here, let's see, right in this region is where the tower actually collapsed, and then it kind of flatlines. The anemometer could still flop around a little bit in the wind, but it's sitting just a few feet off the ground. Another thing that's interesting is look at our temperature range right before that event. We're really in this sweet spot for icing here. Granted, we could have had icing at lower or warmer temperatures, but we hit it really nice, and I won't use the cliche of a perfect storm. So we go back up, and here's what we're looking at. And at the time, we figured, okay, it's icing. We didn't know how bad, because by the time we got back up there, things had cleared off. It had melted off. In fact, Nome, being up on Newton Peak in the wintertime, is quite gorgeous. Even though it might be 10 below Fahrenheit, you get some nice sun on you, and if you're out of the wind, it's just beautiful out there. I highly recommend it. So here's Bob Hafner, and he's standing up on Newton Peak when they went back up to fetch some of the material. These are solar panels, and these are the guy wires, and you can see how much ice is accumulating there. And again, here's that FAA station, the transmitter and solar panels here. These are some solar panels and an antenna. And here it is when Bob went back up, to just kind of give you a scale of what type of icing we're looking at there. We've actually lost 2 towers up on this peak, and the first one there was a variety of factors that could have been the cause. This one here is pretty conclusive, and so we've abandoned that site. So just to kind of summarize your key takeaways here is that supercooled supercooled liquid will exist in a cloud well below 0 degrees C. I highly recommend doing meteorological studies prior to wind development. I say that because there's been there's a few examples where that has not been the case, and I think we've experienced problems in each case where we haven't done those necessary studies. And then here's another thing too, is that sometimes we have a fear of icing so bad that we're afraid of some of these higher elevation sites, while at the same time we may be losing some potential wind energy. And to just suspect that, well, you go up in elevation, you're going to have icing. Some people get the impression that if you're down low, you won't, and it's not a either or. There's a gradient, and right now we don't have the models. We haven't studied things sufficiently to understand that with terrain in this region, with these other features of moist air and things like that, of actual elevation change, how much icing will you really get if you go 100 meters more in elevation, or another mile back, those kind of things. So we haven't done that. I have some ideas of how to come in and quantify, do some modeling, but we don't have funding for that yet. But if you want to work, if you have some ideas, I'll be happy to share those with you. So don't be so afraid of icing that you stay away from the good wind regimes. The other thing is that sea level, we see some significant icing events at sea level too. So it just depends on what the conditions are. Some of the places we've looked at in Napakiak, there's been multiple icing events there, and they're at about 12 feet elevation, right off the Kuskokwim River, pretty close to where Kuskokwim Bay starts. And so you'll want to find those balance between wind, good wind, and icing losses, and quantify those. And each site, I think, is very site-specific for its terrain and predominant winds and moist air masses. And some icing can impact turbine output and even affect the turbine survivability. We have some concerns out in the Aleutians for icing as well as extreme wind events. And yes, it's class 7, looks great on a map, but do we want to put equipment out there? Is it going to fail? Is it going to cause damage to people and property? So all things to consider, and all things that can be answered doing studies up front before you go erecting wind turbines. Thanks.
Any questions for Rich?
Is there equipment out at Cape Newinham yet?
Cape Newinham, if there is, it would be something federal government related, whether it's Coast Guard or FAA, something like that. We don't have any utility scale wind power there.
Do some of these places like Nome have recorded weather data over time? It seems like some of them have had weather stations.
Yes, and you can see, you can get the weather data typically from the airport. There's also other RAWS stations that might be able to that you can mine the data first and see what kind of icing. But we typically look at that just for basic wind information too. So the icing, you should be able to pick that up by sudden drops in wind speed.
Yeah, one of the problems certainly is the wind. Icing is very specific to where you're putting the wind turbines. So it'll give you an indication, but won't tell you how bad it's necessarily going to be.
I was just curious about the characteristics of the ice. Is this something that is, can be knocked off with a brush, or does it need a shovel? And I'm wondering if that would be different perhaps on the coasts or inland like in Whitehorse.
I can answer that.
Yeah, I was gonna say, you probably don't want to take a hammer to your, to your blades. But some of it can vary, but I'll let Ian talk about that.
Yeah, I mean, we get three kinds of icing. One, and it depends on where you are. Certainly glaze icing, which is freezing rain, which can be very hard, very hard to get off. Then we get the rime icing, which is this wind-driven, super cooled particles. And then, any other questions?
Has there been any testing done as to what surfaces or coatings would actually work the best with these types of ice?
Yeah, I'll let Ian answer that.
Yeah, there's a fair amount of research. Some that are commercially available, as was mentioned by John. Others that are undergoing tests all the time. People are trying to come up with new coatings, looking at the different icing structures, both aquaphobic, hydrophobic, or icephobic, to keep ice from forming on blades. Some very successful. So certainly something to look at if you're putting turbines in places that have icing. It's a relatively low cost